Okay, guys, long video here. So this is for both honors and non-honors. Okay, for these three shapes, we have to know that this guy, when we start with a circle, our little pirate square, that means pi r squared. So for the cylinder, we start with our circle, pi r squared, which is this shape right there. We start with our circle, and then we just pull the circle straight down, right, and give it some height. So circle times our height. I'm going to do this in two colors. Times our height is what we got. So, and that's volume. So volume equals, I'm not going to do this, 3.14 times the radius is 4 to the second power, so times 4, and then times height of 2. So if you do that all in your calculator, 3.14 times 4 twice, right? Times 4 squared, or times 16, whatever you want to do. 3.14 times 4 times 4 times 2, you're going to get your answer. And you have to say volume equals, tell me whatever it is, and then it's 3D units. All right, the same thing for here. We start with this circle up here. Boom, we start with a circle, so that means we have to start with our pirate square. Our pi r squared. We have to give it some height to make it tall, so multiply by height. But then when we crush the bottom, we have to divide by 3 because we're only getting this area now. We're only getting this area. We lose out on the other two areas. We lose out on here and here. So we only get 1 out of 3, so we divide by 3. So equals 3.14 times the radius twice, so 5 squared will be times 25, or you can just say times 5 times 5. And then times the height of 6, and then divided by 3. And whatever that is, we're going to say the volume equals that many units to the third power, or 3D units. All right, for this one, we start off with a circle, just like the other one. We start off with a circle, right? But we're not making a circle tall. We start off with our pirate square, our pi r squared. We're not making a circle tall. We're making it 3D. So I'm going to get rid of that second power and put third power for 3D, but we need that stupid fraction in front. It's the only thing you really have to memorize. So in here, the volume equals, I'm in my calculator, I'm going to do 4 divided by 3 and hit equals, and it should say 1.33333. And then I'm going to multiply, I'm going to say times 3.14, and then times 7 3 times, times 7 times 7 times 7, and you should get an answer, volume equals, and then you're going to say 3D units. All right, over here, we've got a squared plus b squared equals c squared. Let's see, that's 8, and this is, I should have made this, 18 squared plus 24 squared. These are in your calculator, so 18 times 18 plus 24 times 24 equals, I don't know, squared. I don't know what this number is, but I'm going to take the square root of it, and whatever the square root gets, that's going to be your answer. C is going to be that number. So I'm doing these without a calculator today to make you do some, but that's how you do it. All right, these guys, number 5, let's see. We've got 2x's and negative 10x's on the same side. So really what we have is negative 8x's. Over here on the same side, we've got positive 5 and positive 4. They're both numbers, so we can combine them. Really, we have plus 9 equals 33. Now, I've already made my teams by color, so I got to send the 9 to the other side. Minus 9, minus 9. So I get negative 8x equals 24. Divide by negative 8, not by 8, by negative 8. And x equals 24 divided by 8 is 3. Nothing killed this negative. There wasn't another negative on top to kill it, so the negative survives. X equals negative 3. All right, for the next one, 4, this is Starbucks list. 4 times negative 2 is x is negative 8x. 4 times positive 3 is positive 12. 8 times 3 is 24. 8 times negative x is negative 8x. We have the same amount of x's on both sides. Whenever that happens, they're going to cancel themselves out when we add 8x to both sides. So we're left with 12 equals 24. That is not true. That is never true. There's nothing that will ever make this true. No solution. All right, substitution. Anywhere I see a y, I can plug in 3x minus 4. So I'm going to take out this y. I'm going to plug in 3x minus 4 equals 10x plus 17. I'm going to make my teams. I'm going to send I'm going to send this guy, I'm going to minus 3x over here and put him over here with his partner. I'm got to get rid of minus 17, so he's dead here, dead there, equals 7x equals negative 21. 4 people on the negative team, 17 people on the negative team. I divide by 7, x equals 3, but nothing killed the negative, so negative 3. Once I know x equals negative 3, I plug it back in here, and y equals 3 times negative 3 minus 4. Y equals negative 9 minus 4. They're all on the negative team. Y equals negative 13. Okay, let's see. Substitution over here. We're going to take anywhere we see a y, we can plug in 3x plus 2. So over here I see a y. I'm going to plug in 3x plus 2 instead of the y. Everything else in black has to get copied. 2x plus 3 times that equals negative 16. Now the 2x comes down. Starbucks, positive 3 times 3x is positive 9x. Positive 3 times positive 2 is plus 6 equals negative 16. We have 2 guys on the same team, so let's combine them. 11x's plus 6 equals negative 16. I color-coded my teams already. So minus 6 from this side, I got to send him over there. Gets rid of it. 11x's equal, did I do this wrong? What did I do wrong? 9x plus 6 minus 6. No, I did it right. Minus 22. Minus 22. Divide by 11. X equals 2, and nothing killed off this negative, so negative 2. Once I know it's negative 2, I plug it back in there. Y equals 3 times negative 2 plus 2. Y equals negative 6 versus positive 2, so the negatives win by 4. All right, so negative 2, negative 4. All right, over here, number 9. If you multiplied by 3, you were so close. But if I multiply by 3, this becomes 9x, which is what I want, but it needs to be negative 9. So I need to put this as negative 3, and the negative makes all the sign switches. So 4 becomes 12y's and switches to negative, and 18 becomes 54 and switches to negative. They don't always all switch to negative. They just happen to be all positive now, so they all switch to negative. If one was a negative, it would switch to a positive. Okay, so now let's add the rows. Negative 9x's and positive 9x's, those cancel out. Negative 12y's and positive 3y's is negative 9y's. Equal negative 54 and 27. The negatives win by 27. Divide by negative 9. Y equals, the negatives cancel out on this one. 27 divided by 9 is 3. Once I know that, I pick an equation to work with. I'll work with 3x plus 4y's equal 18. But if a y is a 3, then this is 3x plus 4 times 3 is 12 equals 18. Once I subtract the 12 and move it over here with its number partner, I've got 3x equals 6, divide by 3, and x equals 2. So this is 2, 3. All right, let's see, number 10 and number 11. Number 10, this one goes down 10. This one goes up 2. Okay, down 10 over 2 is negative 5. So we start off with y equals negative 5x. And then I was nice. I gave you the begin on blue number, minus 2. All right, over here. This one goes up 4. This one goes over 1, so it's 4 divided by 1. The slope is 4. Once we know the slope, we say y equals 4x. But that's not right. I don't give you the begin on blue number. So is our y 4 times our x? Let's see. Here's one of our x's. I'll multiply it by 4 like the equation says to do, and that's 100. But we're shooting for 103, so we need 3 more. There's our equation. Remember, rational or irrational. These just mean, rational means fractional. Remember how you just add this f and the c? Can you turn it into a fraction? Not if it goes on forever without a pattern. Nope, irrational. Not if pi goes on forever without a pattern. Nope, irrational. Square root of 17 is not a pink number. 16 would be cool, but not 17. So 17 goes on forever without a pattern. Nope, irrational. 47, yeah, I can make that a fraction. I just put a 1 on the bottom. Negative 47, rational. All right, these guys, the slopes of 13 are up. It's positive because it's using my right arm. This is going up. So it's positive. It goes up 1 over 3, slope 1/3. 14 is this sideways one. That's perfectly flat, so its slope is 0. It's not going up. It's not going down. It's perfectly flat. This guy, 15, is going down, so I know he's negative, and it's going down 1 over 1, which is just negative 1. And the slope of 16 is going perfectly straight up and down. That's illegal. That is not a slope. That is not skiing. That is falling. That's undefined. All right, so when I know the slopes, I just say y equals 1/3 x and y equals negative x. Let's see, where does number 13 start? Number 13 starts over here at 4, so plus 4. Number 15 starts up here at 1, 2, 3, 4, 5, 6, 7, 8, 9, so plus 9. So we're done with those two. The weird ones. All right, number 14 that goes sideways. Number 14 right here is the important spot. Number 14 hits the y-axis at 4. So we just say it hits y at 4. That happens to be the equation, y equals 4. Number 16, the only important spot is that it hits the x-axis. This is the x-axis, right? So it hits the x-axis at 1, 2, 3, 4, 5, 6, 7, 8. It hits the x-axis at 8, and that's the equation, x equals 8. Okay, function for 17, yes. If I hit button 0, I know what it does. If I hit button 2, I know what it does. If I hit button 3, I know what it does. I don't care that they do the same job. I just need to know if I hit a button, I know what it's going to do. If this was over here, that would not be a function, because what happens if I hit button 2? Is 4 going to happen or 5 going to happen? That would be illegal. As long as I know what happens when I hit the button, I'm good. And this one, not a function, because what happens when I hit 2? Is 1 going to happen or is 6 going to happen? Don't know, not a function. This one, not a function, because if I do a vertical line test right here, I hit a bunch of spots. I hit right here, I hit right there, I hit right there. And on the x line, this is negative 1. So when we try negative 1, is this spot going to happen, which is negative 1, 5? Is this spot going to happen, which is negative 1, negative 1? Or is this spot going to happen, which is negative 1, negative 4? So yeah, illegal. You cannot have things directly on top of each other, because what happens if I hit negative 1? I don't know. Is that happening? Is that happening? Is that happening? In a graph, if they're on top of each other, illegal. Okay, these ones, we're still not great at these, but they should be easy. We use pink numbers. 1, 4, 9, 16, 25, 36. These are the perfect squares. 49, 64, 81, 100. And we try to use the biggest one we can to use multiplication to break these into two parts. The biggest one I can use for 45 is 9. So 9. And then the other one doesn't have to be pink. 9 times 5. For 100, for 700, it's going to be pretty much any of the hundreds. It's going to be 100. Square root of 100 times 7. But that's not the answer. That's just how you get to it. The reason we use a pink number first is because it has an answer. The square root of 9 is just 3. The square root of 100 is just 10. The back number, it has an answer, but it goes on forever. So actually, the proper way to write the square root of 45 is 3 times the square root of 5. And the proper way to write the square root of 700 is 10 times the square root of 7. So we're still not great. Even though it's easy, we're forgetting those ones. All right, write in scientific notation. We pretend there's a decimal right here, so 7.5. And we're going to have to multiply by 10 1, 2, 3, 4, 5, 6 times. For this one, we would pretend there's a decimal right there after the first number, so 2.8. And we would have to move backwards 1, 2, 3, 4, 5. So times 10 to the negative 5. All right, so if we start with 6.42 and we move the decimal back 3 times, 1, 2, 3, it would have to be 0.00642. That's way too big. That's what it would be. If we started with 8.21 and we move the decimal forward 4 times, it would be 1, 2, 3, 4. 82,100. All right, for 25, 26, 27, 28, these are 2 problems. We've got the normal problem, which is just 3 times 7, which is 21. And then we've got the powers problem, which is 1 less than what we're supposed to do. So 1 less than multiplication is addition. We just add the powers. So for this one, there is nothing less than subtraction. So sorry, there's nothing we can do. For this one, we have the normal division, which is 12 divided by 2. Those are just normal numbers, so that's 6. For the powers, when we divide them, we don't actually divide. We do 1 less, which is 1 less than division is subtraction. So 10 minus 5 is 5. Over here, we have the normal number, and we have the powers number. When we take the normal number to the second power, that's just normal powers. 3 to the second power is 9. When we try to do the powers number to the second power, we don't do 49. We do 1 less than powers, which is multiplication. So we don't square it, we just do 7 times 2 is 14. So all of these are like 2 problems in one, a normal problem and a 1 less than problem, like a powers rule problem. All right, how far are these apart? We make a right triangle to make our legs so we can find out how far this is. Okay, let's see. Counting the boxes, this is 1, 2, 3, 4, 5, 6, 7, 8. This is 1, 2, 3, 4, 5, 6. Using my a squared plus b squared equals c squared, I've got 8 squared plus 6 squared is I don't know squared. 64 plus 36 is I don't know squared. 100 is I don't know squared. I take the square root. C is 10. So over here on the triangle, 8 and 6 don't add up to 10, right? But if I take them all to the second power, they do add up in right triangle. So 8 to the second power is 64, plus 6 squared to the 6 to the second power is 36, and 10 to the second power is 100. So they add up when we square all of them. So at the very end, when you get 100, that's not the answer. You have to take the square root to go back to 10. So you square them, you turn 8 into 64, you turn 36 into 6 into 36 to get 100, and then you have to turn 100 back into 10 with the square root. All right, let's see. We'll do both of these really quickly. For regular, -4 plus 6, 1, 2, 3, 4, 5, 6. Let's see, I'm going to do this really fast because the phone's ringing. Down 1, 2, 3, 4 over 1, down 4 over 1, down 4 over 1, boom, and -9, boom, right there, 3, -6. All right, gotta go.